for a person to get killed in an electric chair, we will use the differential equation for electricity, wherein L is the inductance, I is the current, R is the resistance, Q is equal to charge, C is equal to the capacitance, and E is equal to voltage. Given that a human body can be a 1,500 ohm resistance, and it can be a 100 picofarad capacitance, and an electric chair has a constant 1,000 voltage. Obviously, at time equals 0, the charge is also equal to 0. Now, for the charge it takes for a person to get killed is only 0.1 amperes. I is also equal to dq over dt, therefore dq over dt is equal to 0.1 amperes. Now, for this equation, since we are not given any inductance, this part will cancel out. So we set up the equation substituting all the values we have. 1,500 resistance, which is here, and I, which is dq over dt here, q over c, this one is a capacitance, then the voltage is 1,000. Now, we divide by 1,500 to remove the constant beside the dq over dt in order for us to use the linear differential equation. Having this, we'll have this value, q over 1.5 times 10 to the negative 7 is equal to 2 over 3. Now, for the linear differential equation, we'll be needing to solve the integration factor. Now we have this equation, we can now set up the limits 0 to t, 0 to q, and 0 to t. Now, using integration, we'll get q e raised to t over 1.5 times 10 to the negative 7 is equals to 2/3, the constant, and the integration of this one, which is 1.5 times 10 to the negative 7, bracket e raised to t over 1.5 times 10 to the negative 7 minus 1. Remember that e raised to 0 is always equal to 1 and not 0. Now, we divide the equation by e raised to t over 1.5 times 10 to the negative 7. We'll get the value of q, which is equal to 2/3 of 1.5 times 10 to the negative 7, 1 minus e raised to negative t over 1.5 times 10 to the negative 7. We derive the q with respect to time in order for us to get the value of I, which is 0.1 ampere. Now, by differentiating, we'll get the values 2 over 3, 1.5 times 10 to the negative 7 over negative 1 over 1.5 times 10 to the negative 7. This one will cancel out. And the negative here will also cancel out over here. E raised to negative t over 1.5 times 10 to the negative 7. And the resulting value will be 2 over 3 times e raised to negative t over 1.5 times 10 to the negative 7, which is equals to 0.1 ampere. Moving here, we transpose the 2/3 on the other side, and we'll get 0.15 is equals to e raised to t over 1.5 times 10 to the negative 7. We're gonna use ln on both sides. We'll get ln of 0.15 is equals to ln e raised to negative t over 1.5 times 10 to the negative 7. ln e will cancel out, which will be equal to negative t over 1.5 times 10 to the negative 7 is equals to negative 1.897. Isolating t, we'll get the value of negative t is equals to negative 1.897 times 1.5 times 10 to the negative 7. And we'll get the value of t, which is 0.28 microseconds. Which the conclusion is instant death.